Hi, hope you all are doing well. So today I'm here to discuss about the proposed scheme that I developed way back in 2021, and that was the modified control nearest level control for full bridge based submodule topology. So, if you are doing literature on the MMC HVDC converter schemes, so you would come to know that in MMC there are different types of submodules, and most common submodules you will come to know about the half bridge and full bridge submodules. So the half bridge submodule is the one in which there are two switches and one capacitor, whereas the full bridge submodule has actually four number of switches and one capacitor. So the benefit of using full bridge submodule compared to half bridge submodule is that the full bridge submodule can produce positive as well as negative voltage and zero voltage. So this is one of the advantage of using full bridge submodule. Secondly, whenever there is a DC fault on the HVDC line, so the full bridge submodule has capability of blocking DC fault current compared to H bridge submodule, where whenever the fault occurs, the switches uh, you know do not operates, the diodes and the time operate. But here in full bridge submodules, whenever the fault occur, so the DC voltage that is provided by the submodules, their sum basically provides certain resistance, kind of resistance to the fault current, and that is basically the time when your HVDC breakers gets in operation. So this is basically the theory. You can learn it from the internet, but here today I'm going to discuss about the full bridge submodule. So this is my paper in which I have described the modified nearest level control. So this was totally developed by me when I was working in way back in 2021. Okay, so let me show you the model. So this was the model. So in the model we have a full bridge. This is the full bridge, right? And here in this full bridge we have a four switches and one capacitor, right? And we are operating it with a four different signals. So we need four different signals for each submodule. Okay, so we have four submodules that are connected in series, either in the upper arm or in the lower arm. So this one is the upper arm and this one is the lower arm of the full bridge submodule, right? So let me show you the results. So basically these are the results, and at 0.5 seconds I am enabling the control for my full bridge. So at 0.5 you can see now, as per the literature, that the full bridge submodule will provides us the 2N+1 output levels when there is a conventional control applied to it. So as per the report, we are using the four submodules. So as per the four, we will get 2N+1, means 2 into 4 plus 1, 9. So we can see that there are 9 levels in the output voltage waveform before 0.5. And after that, the scheme that I developed, in that what we are getting is basically 4N+1, means 4 times the number of submodules in the upper or lower arm plus 1. So we are getting 17 output levels in the MMC, right? So we get 17 output levels. So the operation, you can learn that how basically I am doing it. So this is my theory, that as per my theory I have so here you can see in this these 4 bits of modules are connected in series, and I have named each submodule. Say suppose they are connected back to back, right? So the switches that occurs on the left side I named as a left arm. I say that these are forming the left arm, and the switches that are available on the right side, I say that they are forming the right arm. Now, based on this assumption, I have developed the scheme to operate this full bit submodule. Yeah. So basically, it's quite complex, where I have many signals, and I need to uh, reroute them to their destination, and send them here on the submodules, and till and the to the switches. So further you can go through this paper, and yeah, I have done lots of work in the lab view and as well as in the Matlab. So you can see the results. Now later on, the same results were obtained using the real-time simulation setup, where we deployed the same model basically in the multisim, because multisim was capable enough to be loaded into the PXI. We can also deploy the model of Matlab, but due to the co-simulation we were able to do that time, so I did that using LabVIEW and Multisim, and later on I used the same model to be deployed on the RT Hill simulation setup. So after that, we were getting the same results using the RT Hill setup, where I showed that if the load is varied, how the waveform will, like current waveform will, behave, and several comparison schemes. So this is all about my paper. So yeah, you can do such work. So this was never done before, like in the literature I was the first person that suggested or produced the modified control for using the full bit submodules, and the levels were up to the 4N+1. So this was the novelty from my side that I did. Okay, so yeah, that's all about this paper. Let me show you my work on the work with 8 submodules. So basically this was the model with 8 submodules. So you can see that there are basically 8 submodules connected, and these are the full bit submodules, right? So in the paper you can see that basically I have simulated the system with the 4 and 8 submodules. The 12 submodules are also used. So with the 8 submodule, you can see that basically the control is initiated after 0.5 seconds. So before 0.5 second, you can see that this is the conventional control, where I am getting 2N+1 output levels, and since the number of submodules are 8, so you can see that 17 levels will be presented in the output voltage. whereas after 0.5 seconds, so let me zoom it. Here you can see that the output levels are basically 4N+1, and the output becomes purely sinusoidal uh, after the 8 submodules. It becomes purely sinusoidal, and the THD is very low compared to uh, the results with the 2N+1, which is the conventional control. So yeah, the signal routing becomes very complex. The wiring gets very messy because we are using the 8 submodules per arm. So yeah, this basically takes time. So this is all about my work. If you have any question, you can definitely ask me in the comment section. I will definitely reply to that.